Hello, everyone, and welcome to another episode of Mainstream Modular, a podcast from Guerdon. I'm your host today, Tyler Kern. Welcome to another episode of the show. We're thrilled to have you along with us here today. Our topic for today's episode is circular economics and how that relates to modular construction. We're going to talk a little bit about the waste that's created in the built environment, the ways that modular can help combat that, and a little bit more about what it means to operate in a circular economic kind of way. And so joining me is an expert on this topic. He's going to help explain these different concepts for us here today. It's John Killingsworth. He's an associate professor of construction management at Colorado State University. John, welcome to the show. Thanks for joining me.
Thank you. Appreciate you having me.
Absolutely. We're thrilled to have you on the show here today, John. And so, one of the first things that we have to establish just kind of as we start this conversation is just discussing the kind of waste that currently exists within the built environment and within the construction industry in general. So can you explain that problem that the built environment currently has when it comes to waste under the current way that we operate?
Yeah, absolutely. So, the construction process inherently has a lot of waste in the process, right? The new construction produces well over 20% of the solid waste that goes into the landfill. And that's just the process of building, right? And that number gets significantly higher, in excess of 30%, when we consider the waste that is produced by demolition of old buildings when they reach the end of their useful life.
Yeah, that's a great way of putting it. And, I spent a number of summers with my dad, who was a general contractor and, remodeling homes. And I remember carrying as much, drywall as possible out to just different trash bins and things like that. And so I remember at the time feeling like, hey, this is a lot of stuff. And the numbers really bear that out. And my exhaustion at the end of the day really bore that out as well. But the built environment has always operated in what you refer to as a linear fashion, right? A linear economic model. Most people out there probably already understand this, but for some who might not, explain what that means by linear and why we are thinking of it in that fashion.
Sure, yeah. So, any industry that makes products, right, has in the past just followed this sort of linear approach, right? We extract raw materials from the earth. We use that raw material to, refine and create other products or other materials. We use those materials in the production of goods. And then, of course, right, we put those into the economic cycle. Well, when those products reach the end of their useful life, they're just commonly disposed of, right? They're just thrown in the trash bin. And in construction, it's really the same thing, right? We take massive amounts of materials from the earth. In fact, it's estimated about 60% of all of the materials that are extracted, right, from natural resources are used to build the built environment. So 60% of that material is going and creating the built environment, creating the buildings that we live in, that we work in, that we are entertained in, right, that are part of society. And and then if those buildings reach the end of their useful life quickly, then they're just demolished and thrown into the landfill. And instead of a more sustainable or more circular method that would try to keep those places in the economic cycle for longer. So that process is exhausting natural resources. I mean, that's well documented. We know that, we see it, we feel it. And of course, it's creating significant amounts of waste that's going into the landfill, and that's an environmental, problem, impacting the soils, impacting the water system, impacting the natural environment. So we've got to get away from that linear thinking and find solutions that are more regenerative and renewable and more circular, right?
Absolutely, absolutely. So before we dive in and talk about circular economics and what that means and how this can apply to the built environment, especially in modular construction, there's been a big focus on sustainable products and thinking about how do we create more sustainability in the products that we use, and that leads us down a certain road of thinking. Give us your thoughts on kind of the common let's call it the common wisdom, I guess, the prevailing wisdom as far as sustainable products, and maybe why they miss the mark slightly.
Well, and so I wouldn't necessarily say it's missing the mark. It's like getting closer to the mark for sure, and that's, and every effort there is therefore beneficial. So in the early '90s, the construction and design industry started looking at more sustainable ways of building. And we needed to define what that is, right? So you had organizations like USGBC and BREEAM and Green Globes and a number of other building rating systems sort of emerge and try to define what is a sustainable building and what does it mean to build sustainably, right? Well defined. In fact, a colleague of mine who just recently passed away, Charles Kibbert at the University of Florida, really wrote the book on sustainable construction and helped push, right, us towards that. And he was a part of the early USGBC organization. And so sustainable construction is defined loosely, right? Meeting the needs of society today without inhibiting future generations from doing the same, right? So if we think of it from that perspective, I think we're still trying to achieve sustainability. But the way that buildings are measured today in terms of, right, those rating systems, I think they still come short of what really needs to be the goal or really needs to be the objective.
Is there an example that you could share maybe of what that means or what that looks like in practice, perhaps?
Yeah. So, in fact, just last week I was visiting the California Academy of Sciences in San Francisco, Golden Gate Park. Wonderful, creative building, and it meets LEED Platinum for its construction and design, and it meets the LEED Platinum for its use as well. But when we toured the building and began to learn, right, some of the elements that were designed into it, we began to find like, wow, okay, so it meets sustainable standards, but it's not necessarily built for like a circular model or circular economy. And for instance, the solar panels in the eaves are built into the glass, and the architect wanted the panels to be integrated into the glass eaves, which is now presenting some interesting problems. One is it's just not easily to replicate those and reproduce them. It was very, very specialized in terms of its production, and would be just impossible. Well, not impossible, but really difficult to replace those panels. And the way it was designed, it's actually not generating a lot of the energy that it was intended to generate. So, not very regenerative in its design. So, and that's, again, it's not a criticism at the designers, from 15 years ago. They were working toward that eventuality or the goal of greater sustainability. But now looking back, right, we have the benefit of looking back and being critical of some of the material choices and so forth that they made in that building. The demand for cooling is a little bit higher than they expected, and we're all experiencing some climate change, right? And so the demand on the cooling towers in that building is increased, but the way it's designed does not allow for expansion of that. And so they'll have to customize or create customized cooling towers in order to keep up with the demand. So, right, that's not a very circular model, but the building meets high levels of what we consider sustainable building. So, so there's an example for you.
Yeah. No, that's a great example. So we've kind of danced and touched around the circular model and what that means and what that looks like. But give us a high level view of circular economics and how it applies to the built environment.
A circular economy is one that is that approaches design and production of products to extend life cycle, right? And then to eliminate waste in the process, in the manufacturing, or in our case, like the building process, right? So trying to eliminate waste, trying to extend life cycle, keep it in the economic cycle for a longer period of time, right? You think about the blockbuster videos that we built in the 90s, and there were thousands of them all over the country. And right, and those buildings, right, obviously don't serve the same purpose they did when they were built, and many of them were just simply demolished to make room for whatever next retailer was coming into town, right? So, right, we sort of missed that opportunity to look at it and say, well, how can we use these buildings? How do we keep them in the cycle? And are we building in a way that we can keep the buildings in the economic cycle or in use for, longer than 20, 30, 50 years, right? Can we build buildings that are in use for hundreds of years? And not to deviate too much, but one of my favorite things is to take kids, my students, to Europe. I do this every year, and we get a tour, the built environment of Europe, and they get to see some of the really great things that they are doing and that they have done. And one of the favorites, of course, is walking through these cathedrals that are still in use, right? 1,000 years, or 500-600 years after they were built, which is remarkable, right? And still serving that purpose. So we got to start thinking about that. That's part of building in a circular fashion. But it also means building regenerative or renewable ways. So that means, building in such a way that, right, captures carbon emissions or captures and treats water in the system and generates its own energy that it's consuming, those kind of things too. That's part of that process as well.
Absolutely. No, I think that's really well put. And I love the example of Europe and kind of looking and seeing what they're doing and what they have done in the past. I think it is a great way of thinking about it and putting it. And so you and I have talked about this. And one of the things that you pointed out is that there are 5 fundamental principles that guide circular economic thinking. And so we're going to walk through each of those principles, but then also explore how they relate to modular construction, kind of as it relates back to this general podcast and some of the themes that we cover. And so let's start off just with those 5 main principles. And the first one you have is build in layers. Tell us what that means and how that applies to modular construction.
Yeah, absolutely. And let me just sort of precursor that by saying these 5 principles are set out in a text by David Cheshire. So I definitely don't want to take credit for these. And of course, he's building on a lot of the work that researchers that have done recently on the topic. But he's done a really good job of defining them for use or application in the built environment. So yeah, that first one is building in layers. The idea here is that if we can create a building that is sort of built in layers, and those layers are accessible, then as it reaches the end of its initial purpose that it was designed for, perhaps we could peel off some of those layers, right? Retrofit it, upgrade it, and keep the building in its use, right? Some of the most what's the word? Energy consuming process is actually in the superstructure, or the shell, if you will, of the building, right? So concrete and steel, and in some cases wood, right? So the structure, the skeleton, or the foundation of the building, right? That's sort of a primary layer, if you will. We want to keep that. That's energy intensive materials to get in place. So we want to keep those materials in place, as long as we can. And then we've got other layers like the envelope, right? And the roofing, right? The envelope, keeping up the bulk moisture and controlling the vapor moisture and that sort of thing. We've got systems inside, like your mechanical, electrical systems, right? Which in the way we build right now is often inaccessible until you peel off, right, some of the finished layers as well. So we want to start thinking about, okay, well, how can we design in such a way where I can easily access those layers, and then retrofit the building or remodel in some cases, right? So that we keep it in service for a much longer period of time.
And by nature, the way that modular construction works, does it kind of lend itself to building in these layers the way that you're discussing?
Yeah, absolutely. Which is interesting, right? I think it's an interesting byproduct of the way that Guerdon and others build modular volumetric is because they're creating these layers and they are accessible. They can do this. So right, the stacking of the modules, for instance, is great because, right, what if you need, in fact, the core itself, or the box itself that's an oversimplification of what they're doing. But right, what if we could take those boxes and get them retrofitted and back into service in another form or fashion quickly? That's a great way of building in layers.
So our second fundamental principle today is designing out waste. And that's obviously going to be a massive one as we discuss circular economics and circular thinking when it comes to the built environment. Tell us a little bit more about designing out waste and what that looks like and how that's achieved in modular construction as much as possible.
Sure. Yeah, you even mentioned as a kid, right, helping your dad and hauling out all of the scraps of lumber that are cut off, and the massive amounts of drywall, right? And you're right. It just, whenever we do a customized space, we have a lot of waste. Drywall is an easy target, but the framing system is too. And so if you look at, and if you get a chance to experience, right, how Guerdon is building, they actually control their waste significantly, because anything that's cut off is actually stored and used as blocking, or right, drywall blocking, or used for the electrical blocking, mechanical blocking. And so there's all sorts of uses for scraps of wood that are left over from, I got to cut 2.5 feet off of this board, and that happens multiple times throughout the framing process of a building. Well, most construction sites, right, they're trying to control some of that, but honestly, right, the priority is production. When you're on a traditional built, it's the labor hours are more expensive than that scrap of wood. And so if it takes you more time, right, to just chase down where that scrap of wood is, to make use of it, it's financially not a good model. So, and so when we're talking about circularity, by the way, we're not just talking about wasting materials, but wasting other resources. So obviously human capital is a significant waste. Well, so the modular process is recapturing a lot of that, because they have a controlled area where all the scrap right pieces are stored, and it's pretty neat to see how they work that. And honestly, that's remarkable. They don't throw away a lot. Drywall, for example, instead of dropping the ceiling down in a framed system and then drywalling it, they actually will frame the entire ceiling system of a box, right, and wire it, and then drywall the entire ceiling, and then drop that down on a unit. And so your partition walls, which normally in a traditional built are interrupting, right, the ceiling, if you will. Well, in this case, the ceiling is continuous, so they actually eliminate a significant amount of drywall waste just in integrating that process into the system. And right, and they're doing the same thing, trying to explore ways to do the same thing with walls and so forth. So always trying to maximize the use of materials, and because the process allows them to do so, they can capitalize on that.
Absolutely. And so if we move on to the third fundamental principle, I think this one is one of the most intriguing ones to me, just as it relates to how circular economics can work and maybe should work better in the future. And that's designing for adaptability. And so this one's particularly intriguing to me. Explain how we can build more adaptability into our designs and into the built environment.
Sure. This relates very closely with building the layers. But right, there's some level of standardization in the boxes, in the modular units that they're creating, and a lot of that is actually dictated because the transportation system, right? If they're shipping down the highway, they're limited on different sizes, and so what that has done is that's created a necessity for the architects and their designers to think creatively about the space and the adaptability of that space. But yeah, I mean, some of the multifamily housing that they're putting up, it's the same size boxes as some of the hotel boxes that they're building, and honestly could be very quickly retrofitted for medical facilities, right? We were talking about this, close to 2 years ago, about meeting this immediate demand for the COVID patients, and needing to address this sort of, we don't have space for the patients, and we need to slow down this spreading of this disease and so forth. We've got to keep those patients separated from other patients and so forth. And so the pandemic created this demand for an adaptable space. And cities and states got really creative. I know a lot of convention space was quickly converted into medical facilities and so forth. But if we think creatively about a hotel, fundamentally that hotel, if it's built to be adaptable, you could take the head wall out and replace it with a medical head wall that has all of the the gases and so forth, whatever. It's maybe not quite as simple as I'm portraying here, but it's possible, right? And it's and we just need to start thinking about, okay, can we build this to be adaptable? Another example is just simply right, economics and demographics and dynamics of our country changes over years and decades. There's been big booms in natural gas and petroleum products, right? And so areas that are getting built up. North Dakota's experienced a lot of movement because of this, right? And so temporary housing was built and sent to North Dakota to address the housing needs for the boom there. Well, okay, then the petroleum industry sort of goes into a bit slower period. Well, what do you do with all that housing? Well, if it's been designed to be adaptable, well, we can disassemble. Well, I'm kind of getting ahead of myself, but we can disassemble that, adapt the space, and use it elsewhere. So designing specifically to be adaptable is really important in a circular model, right? Keeping most of that material in the cycle for longer.
Yeah, I feel like a lot of the conversation coming out of the pandemic has been, how do we create more adaptable solutions? And this has been the case in software, in healthcare. Everyone wants to talk about how do we better prepare ourselves for the future, but I don't think a lot of people immediately thought about, how do we build more adaptable buildings? How do we have more adaptable structures in the future? But I think that you just kind of made that case and made it really well for how we can do that a little bit more in the future. And you kind of gave us a teaser for our fourth principle, and that was designing for disassembly. And so that kind of plays really well into the idea of adaptability, right? And the ability to disassemble and reassemble in different ways or in different places as needed.
Yeah, and it goes hand in hand, right, with adaptability and building in layers. So if we build for disassembly, we're looking at, okay, when it does reach the end of its useful life, then, what components of that building can be recaptured. The recyclability is actually kind of the lowest tier we want to get to, right? We never want to send anything to the landfill. So let's design to eliminate anything going to the landfill, and that is a lofty goal, but let's get after it. And I, right now, the way we build, we could actually eliminate significant amounts of waste going into the landfill. So let's design for disassembly rather than even deconstruction or certainly demolition, right? But deconstruction says, okay, we can deconstruct this building, recapture some of those materials, and some of it's going to be, good for, we'll recycle those materials, and keep them in the system, right? Disassembly takes it just a little bit further and says, let's make it easy to disassemble and peel off those layers and recapture, most, if not all, of that building system, right? So, so designing specifically for the future potential of disassembly is a critical part. Modular volumetric is a good solution for this because it's designed in such a way that it can be disassembled. We can take the boxes off of each other, right, and even ship them back to the plant and say, okay, well, let's disassemble carefully the pieces, right? So modular boxes are fundamentally the same thing, one unit after another. Some little bit of variation, but ultimately, right, we have those same systems in place, so we don't have to like strip it down to, completely disassemble the thing. We can actually disassemble layers and then reassemble to fit a new purpose.
Yeah, I think that's really well explained and really well put. And you're right to kind of point out the way that all of these things have kind of tied together. And then we'll wrap up here on our fifth fundamental principle, and that is material selection. And again, this kind of relates back to some of the other things we've talked about. But tell us a little bit more about material selection and how that plays into circular economic thinking and modular construction.
Material selection is like at the core of circularity. We are building right now, with massive amounts of concrete and steel. In order to build the buildings that we're building, we're going to have to continue to do so, for the foreseeable future. So what we need to do is look at ways that we can reduce the use of concrete. Certainly, concrete waste. Concrete is environmentally very impactful in a negative way. So just the production of it requires a lot of energy, and then the material itself, if that gets into the water system, is pretty bad. So could we start to explore, when we're using concrete foundations, could we use cast in place foundations? Could we explore things like that are reusable? Certainly steel, right? Somebody mentioned to me actually just last week in that visit to San Francisco, they were talking about how landfill will be the material mining of the future, because it will get to a point where it's so expensive to extract raw materials from the earth that that we'll reach that tipping point of it's actually cheaper to go back into the landfill and start pulling out the metals and recycle those. But I wonder can a building be designed in such a way that we know what is in there? It's well documented, so that we know, the beams that are used and the columns that are used and the sizes and so forth, and so that when that building reaches the end of its useful life and we go to disassemble it or repurpose it or adapt it, we can say, well, look at the repository of materials. We can actually use those materials elsewhere. There's another aspect of material selection too that maybe is competing with this idea of sustainability. And so we have, for instance, sustainable forests, in our country, in Canada, where we get most of our lumber from Canada. And there are sustainable forests. So those are forests that are certified sustainability or sustainable practices, They don't clear cut. They're planting more than they're pulling out. They also use methods that reduce a lot of carbon emissions and so forth in the process of extracting that wood and getting it into production. Well, okay, that's great, but if we consider purchasing lumber from a sustainable forest that is 500 miles away just to get the sustainability credit, when we have, for instance, Guerdon in Idaho, and they have a local forest that actually they can get it, and it's closer than 100 miles away, but it's not a certified sustainable forest. But it is more circular because the embedded or embodied carbon in that lumber is is significantly less than buying it from the certified sustainable forest. So we do need to be very careful about just making assumptions about, what is sustainable, and material selection is a big part of that. We also need to be a lot more cognizant about really what do we need and want in our buildings. Do we really need, the marble that's from Italy, or could we just get it, from Connecticut? And so those kind of things, like we really don't have to have, these labels on materials that we that are desirable, whatever. We can build in more sustainable ways with localized materials. I love the idea of creating a localized economy for most of our building materials, and we can do that in most of the regions in the United States. And so, designers and builders alike really need to be looking at that and informing the owners, like, well, do you really have to have the Corinthian, whatever leather, whatever it is, which, by the way, Corinthian leather is actually from New Jersey. So
the more you know,
right.
you know. That's fantastic. That's fantastic. So those are our 5 kind of fundamental principles that we talk about when we think about circular economics and modular construction. And so, John, when you lay all this out, it sounds really great. It sounds fantastic. But I'm sure that there are people out there who are detractors of this way of thinking. What are some common objections that you have heard, and how do you respond to some of those objections that people out there in the market have?
One, right now, circular economy for the built environment, it's just not part of the dialogue right now. So I think a lot of the problem that we have is not necessarily objections to it. It's educating the users, educating the designers and the builders and the owners. And then when I speak with builders that are familiar with circular economics, they have a difficult time because the owner is really driving the right decisions. And so we need to do a better job of informing the owners of buildings, right? And that includes our governments, and because they build a significant amount of the built environment. But building owners need to be aware of, the future impact of non-circular decisions. And you can see my unfinished basement behind me here. I'm in a relatively new house and relatively very frustrated with my builder who made choices that were not fundamentally sustainable or circular, and but could have actually saved both money, time, and materials, and ultimately provided a better product. But so I think we've got to do more educating. We've got to get this out into the public. So I'll say I appreciate what you're doing here, because that's a little bit of what needs to be done, is informing owners. Like, we need to, look at the way we design and build, and it begins with that decision maker.
So when it comes to educating people and resources that are out there, what sorts of resources would you point people to? Where can they learn more about either the work you're doing or the work other people are doing in this industry, to learn more about the options and to educate themselves just a little bit more?
So I would say I could point them to academic journals, but really that's that's a labor. I mean, you got to really be super interested to derive information. There are
don't read those late at night, right? Like
right.
just never.
Yeah. there is a lot on the internet available, and it is good stuff. There's plenty of resources. There's some fantastic research foundations that are doing a lot. Ellen MacArthur Foundation is doing a lot. They're based in the UK. They've published all sorts of just fantastic papers, and everything's on the internet that they've produced. And so, and it's not just built environment stuff. They've looked at ways to apply circular economy in all sorts of industries. There are some resources with the government. I'm trying to think. The U.S. Department of Commerce actually has some publications or some web pages on circular economy. That's good sort of summary type information. So if you're looking to just get started and get informed, I would start with the internet, and it's easy to find the things that have some substance, that have some meaning and some depth in the research there.
Excellent stuff. John Killingsworth, Associate Professor of Construction Management at Colorado State University. John, thank you so much for joining us today and breaking down circular economics for us and how this can relate to the built environment. It's been a pleasure having you on the show today, and I hope the audience learned as much as I did, because I think this was really fascinating. So thank you once again.
Yeah, I appreciate the opportunity to just share what I'm learning, and I'll continue to be learning myself, right? And so best of luck, and thank you very much.
Absolutely. Everyone out there, thank you for tuning into another episode of Mainstream Modular, podcast brought to you by Guerdon. We appreciate it very much. Of course, stay tuned and stay up to date with the latest from Guerdon by visiting their website. And of course, you can subscribe to the podcast. If you're catching this podcast after it's aired live, you can always subscribe there on Apple Podcasts or Spotify to get the latest episodes right there on your device as soon as they are published. That way you can always stay up to date with the latest insights from Guerdon and from the experts that we have on the show. So you want to make sure to do that. And stay tuned. We'll be back soon with more episodes of the show. But for John Killingsworth, I'm Tyler Kern. We'll talk to you again very soon.